Let me flash the code real quick since I just started recording. Okay, so we'll go back in here. So we got the guy moving in all the directions now, but how do we make it not quite? Look at my floor. It's gotta be with the, in order to get velocity, we need a rigid body. So that's fine. I suppose we can make the mass 0. See if that makes a difference in how it drives. No. I think is kinematic is going to break it. Although is kinematic says we programmatically deal with the physics. So let's see if that, yeah, see that breaks the gravity on it. Because we have to programmatically deal with gravity. So these two don't make sense working together. If we, so similarly, I'll just keep adding stuff to our conversation about this as we go. If I set a collider up as a trigger, that says we can programmatically deal with it. This is on the cube, which means I don't think it's going to react to the other box collider automatically. Just falls right through. So we don't want that guy to be a trigger. Let me try. Well, that's not going to change the collider. By continuous dynamic, make the collision work differently. I don't know why the edge is catching. Let me just do one more thing and see if that fixes our problem. So when I built our floor, we built our floor as a cube. So I mean, at this point, it's solving the problem, right? It's just kind of rolling in the in the right directions. When we built our floor as a cube and just kind of made it skinny. What I'm going to do is I'm actually going to here for right now. I'll just take the floor out. I just disabled the floor. So it's still technically in the scene if I want to mess around with it, but I disabled it for now. What I'm going to do is I'm going to come in here and I'm going to add another object, 3D object. And what I want to do is I want to add something called a plane. All right. And we're going to call this go. Well, I don't know. It's a phylor. Yeah, it's a new word I've invented. All right. So we'll I'm going to go ahead and turn this on its side here. So I'm going to drop this guy down below our cube. And then I'm also going to throw our blue on that guy so we can see the difference between our cube and our other thing. So looking at it on top, we have our cube centered on it. Looking at it from the side, our cube is hovered above it. we see by default, this guy has something called a mesh collider instead of a box collider. No, it's still catching. Well, but we're doing velocity. So the idea is velocity is a physics motion. So you can kind of think that we're pushing it. But it should be, we're pushing it right at the center point. So it shouldn't kind of have like a, yeah. So I mean, it's catching an edge is why it's flipping over like this. It doesn't make any difference there. I wonder. So what we can do is if we go to our cube, I'm going to disable the box collider. Well, I need to stop this guy first. So I'll go to our cube. I'm going to disable the box collider. And I'm going to actually add a different kind of collider. So we can do a capsule collider. That'll be, well, no, because that's gonna still roll. I'm gonna do a sphere collider. All right, so this guy has a sphere collider on it, just a different shape. So if I go ahead and on that sphere collider, I say edit collider, it kind of shows me what that guy looks like. So now it's a circle thing. So I feel like it only has one little point of contact with the ground. But the reality is it's probably going to still roll by my guess. You just make the whole thing a sphere, then we won't notice that it's that it's rolling. Yeah. So okay. So I'm gonna go ahead and just remove the cube. I'm going to add a sphere. I'm going to add a component to our sphere. I'm going to add a script. I'm going to add our box script to our sphere. And then let's look straight down on this guy. Let's look from the side. We need to lift him up. Oh, we need to add rigid body to our sphere. We want gravity to impact this guy. This will be under physics. Rigid body. Turn on gravity, which is the default. So now this guy moves better. We don't have edges to catch. My guess is he probably is actually rolling. That is interesting to me. I wonder why that edge is catching, because the collision, it's almost like when it collided, it let it go like 1 pixel down. So we probably could play the game where we can set it up as a trigger, and then when the ground and the cube hit each other, we then just position the cube up like 2 pixels or something like that. where from our perspective, it's still on the ground, but it's technically hovering above the ground 2 pixels, and then you could drive it around and it would be smooth. So I'm thinking this is how those box colliders, 2 box colliders are, well, 2 colliders are interfacing with each other. But I don't know, interesting thing regardless. But we have our guy driving around in all our directions, including jumping. And we can update our speed a little bit if we want. I think we lost it off the edge. So now this will make them move a little quicker. It is interesting though, now that it is a sphere, we don't have the drag that we had before, so it doesn't actually slow down. Or it probably does slow down slightly, but it's just going to keep rolling just like it was a marble sitting on a tabletop. Yeah, we have to kind of throw it up in the air in order to halt some of its momentum. So kind of an interesting thing. All right, so questions about that in terms of the code to drive this dude around. All right, so let's go ahead and let me just see if I already have it on here. I do have it on here, but we're going to use a tool called GitHub. So if you go to github.com, GITHUB.com. So this is going to be an industry standard tool for effectively doing similar to what we did with online GDB, where you're able to just share a link to your stuff. Now, so if you go ahead and sign up, use your edu address, and that will give you the academic license. You might have to go in and request it, but if you sign up with your cuw.edu, you'll be able to create free private repositories on GitHub, where they charge for those. So the business model for GitHub, and it's owned by Microsoft now, Microsoft bought it a couple years back, is make it free for students and make it so everybody's using it as kind of the industry standard for distributing projects to people. You've probably seen open source projects before where you can download, you can clone it from GitHub or something, so that when you go into the workforce, you bring, I know how to use GitHub with me. And then now that you're maybe going to be using this guy, it's called source control is what GitHub does for you. It's kind of built around the idea of having multiple developers collaborating on a single project, but we're going to use it for storing your projects kind of in the cloud so that you can conveniently just give me a link so I can see your code. Okay. But the idea is that when you're working for an actual business and they're going to create some kind of private GitHub repository, because presumably they have code that they don't want to share with the competitors, they have to pay for that private repository. Screenshot or copy and paste it. Yeah, that one's short enough. So it's, yeah, it was just, we hadn't gotten to this yet. So create your account on GitHub. I'm just going to go ahead and sign into my account here. You know, so I have a bunch of screenshots or a bunch of different projects here. So the projects end up looking like this. So I could just share this link here and it would drop me into the whole code type thing here. But we're going to actually use a tool from GitHub. GitHub's a little bit cryptic to use by default. Once you get used to it, it's not bad, but it is a little bit cryptic. So they have a tool called GitHub Desktop. I'm just going to do a quick search for. So it's desktop.github.com. And you can go ahead and download it. I'll go ahead and download it in case my version is outdated. And what this is going to do is it's going to give us a tool for creating repositories. So a repository would be effectively a folder in the sky to hold your code, where you have a local version and then you commit code to the cloud. And we'll kind of go through that today. All right, so here's this GitHub Desktop. I'm going to just move it into my applications folder, and I'll replace the one that I have in there. So I have the newest one. Windows, it's probably a setup. Probably you have to install it. Same thing. All right, so what I'm going to do here is I'm going to go ahead and open up GitHub Desktop. All right, so I'm going to tell it to stop screening about old things because I don't care about them anymore. So I'm just going to remove that guy. So you won't see all this extra crap over here. These are old repositories I have stored on this computer. So what I'm going to do is I'm going to go to File. Actually, the first thing you probably want to do is go to Git Desktop and Preferences. And under Accounts, you're going to want to go ahead and sign in to your GitHub account once you've created it. That way, this guy knows to talk to your repository. All right. Now, there might be a first time thing where it asks you to put in your first name and your email address, something like that, because I think typically GitHub wants to be able to associate your name and your email address with all your commits. That should only be something it asks you one time. When you do GitHub from the command line, which is the way it's traditionally been used, you have to run two little kind of cryptic commands to make that work. This guy should have it built in there. But once you've signed in with your account, you should be good to go. So I'm going to go ahead and I'm going to say File, New Repository. All right, so we're going to call this guy, what am I calling my Unity thing? Oh, I just called the sample scene. Okay. So we'll call it CSC250 Spring 2022 Unity example. Whatever. All right. So it's saying, where's my local path for this guy? So where do I want to store it? So by default, it's going into my downloads folder inside of a folder called repos for repositories. There's a checkbox here that says, do you want to initialize this guy with a README? You don't have to. Probably for all our stuff, you won't do that. But you can whenever if you've ever clicked on a link on the internet that says, check out the Git repository. Typically when it pops up and it shows you all the information about it, that's what's in the README file. That's kind of like the home page for it. So we're not going to have any we're not going to have any repository README. We're not going to use any license, but you certainly can. These are like the MIT license and the GNU license. This is for open source stuff. We don't care for what we're doing. But one thing we do care about in here is under Git Ignore. We want to go down to Unity. So choose Unity under the Git Ignore. And that's, out of everything we've done so far, that's the most important. Because if you don't do that, your Unity project is a really big file. All right, especially as we start getting into bigger and bigger things, it's going to be like, a gigabyte. It's big. So every single time you want to commit any changes you've made locally to the cloud, you don't want it to have to transfer a gigabyte of crap. All right. So what Git Ignore does is it has a list of all of the files for Unity that are generated locally. So it's only actually storing the core components that make your project unique. Otherwise, when you download those core group of files, however many files it is, when you hit play, it executes all that and it builds it and it generates that gigabyte of crap. All right, so your actual Unity commits are not going to be nearly as large. All right, super important that you set the git ignore. And you saw on that list, there's a zillion git ignores. So this is, you can create your own list of ignores if you're having a project that's more proprietary and it's not using Unity or something like that. But this is the built-in list of git ignore collections that says we've already figured out what you need for Unity, what you don't need for Unity. Choose Unity as the git ignore and we'll take care of the rest. Make some sense? All right, so we're going to go ahead and create this repository. All right, and then what that did is it created a folder in my downloads folder, because that's where I told it to put it. Told it to put it in downloads, called repos. And inside repos, I have a folder now here called CSC250 Spring 2022 Unity example. Now inside that folder is currently empty. Now what I'm going to do here is I'm going to go back to Unity. First, I'm going to look where I'm storing this guy. All right, so this, my project one, looks like it's inside of my my user folder. So I'm just going to hit quit here, right here. Now, you would usually do this the very first time. I'll kind of show you what I mean. When you first create a new project, with Unity, when you create a new project, I'm not going to actually do this right now, but when you do that, under location for where you're going to put that project, you would choose that folder that your repository that you just created the repository for. So create the repository folder first, then put the stuff that you want GitHub to track into that folder. So I would go into downloads, repos, and then choose the folder I created, and then select that as my folder where I wanted to store the stuff. Okay. I'm going to pretend like I did that the very first time by going into my folder here, going into my project one. Well, I don't need to go into it. I'm just going to I'll copy that project. I'll go into my repos, go into that folder. I'll go ahead and just paste it in there. So I've moved it into that folder as if that's where I started with it. Okay. And then I'll just go ahead and delete it from back here. So I've changed its location. So if I click on this guy now, it's going to scream at me, say, I can't find that dude. So I'm just going to go ahead and click open. I'm going to browse to the project I want to open, which happens to be in downloads, repos, in here, and that's my project. And I'll go ahead and hit open. Okay, so I'm going to just go ahead and hit play here. Let's just make sure everything's still working, driving around, all that stuff. Okay, now if I go, so now it's as if I just created this brand new project, put it in my repo folder. Now, even though I created this repository, I'm going to show you over here in GitHub. So when I go to GitHub, let's see if I can conveniently find my most recent, what did I call this guy? I called it CSC250. Spring 2022. Oh, I haven't committed it for the first time yet, so it doesn't show up on here. So when I go to Git Desktop, and I'm in my repository I just created. Notice it has a whole bunch of files in here now, when originally it was empty. And his little green pluses next to it. So this is add files to your repository. Okay, so this repository right now is kind of a specially formatted folder, but right now it only lives on my computer. Okay, so I want to do an initial publication of my repository. Okay, but in order to do that, I need to first commit all the changes. It's saying, hey, here's all the changes I've noticed. Notice it says, I see almost 8,000 changed files. That's why we have that git ignore thing. I see 8,000 changed files. So we're going to just write for our summary here. I'm going to say initial commit. And then I'll go ahead and click commit to main. And main is within GitHub, you can actually have like multiple branches and stuff like that. Like I mentioned, this tool is meant for teams that are collaborating on projects, where maybe you have like the production, the one that's released right now, and then you have the one you're working on for the next, and you have those as two completely separate branches. So if you break the beta, your stable one doesn't break. We're not going to be using it for all those features. We're basically using it to upload our code to the cloud so you can just share a link with me. But this will at least get you started using this tool, because you're only collaborating with yourself, presumably, or if you're working on homework with somebody else and you're having struggles, this gives you a convenient, here's my link to my project, check out my scripts, what am I doing wrong? Something like that. Good. Okay. Well, we can look at it right afterwards. I'm guessing you didn't select the right directory wherever you created your repository. All right. All right. So now what I have done, so it's important to kind of follow these steps. When I first created the repository, that only lives on my computer. I've created a folder with some special stuff inside of it that I didn't have to do, but this tool did it for me, and it only lives on my computer. Then I have committed a bunch of changes. After I started putting stuff into this folder, that folder started noticing, oh, new file, new file, new file, new file. And it kept track of saying, hey, I've noticed all these changes. Now I've committed those changes. I said, yes, I want those to be part of my next publish of the this thing. So that's why I did that commit. So up here, we have this thing called publish repository. You can click it here, you can click it up here. It's up to you. So I'm going to say publish repository, and it's going to ask me some information for github.com. And this is another important step. So it's going to ask you, what do you want your repository to be called? Just leave it as the default name. Make sure you uncheck this, keep this code private. Now, if you're writing your own stuff on there, like I mentioned, if you have a .edu account, you can create private repositories for free if you're working on some side projects or something like that. But I need to be able to click the link and read your code when I'm grading it. So unclick that so it's not private so I can see it. The alternative is you can add me as a collaborator to it, but this will be turnkey. This will just make it work. All right. And then go ahead and click publish repository. And what this is doing now is it is uploading to the cloud. So a commit is a local change. Publishing makes the cloud sync to what you have local. All right. Now, this first publication is going to take a little bit longer than future ones will, because even though we did a git ignore where it's not 4 zillion files in terms of capacity, it's still having to upload a lot of individual things. But keep in mind that from this point forward, we're only going to be changing a couple of files at a time. So a majority of those files that are now in the cloud will stay there in the cloud. All right, so now when I come back here, and I do a search for, just refresh my current repository. So here's this repository I just uploaded. So notice it has, you know, git ignore, git attributes. We didn't create any of those, but here's my projects folder. Here's all this stuff that's in here. You know, so I can go to assets. I can see my scripts. Here's my box script that we've been writing in here. Okay, and that's up in the cloud. So the idea is when you turn your homework in, you would just go into your repository on here and just copy that link. Submit that as your link. All right, that makes some sense. Now, if I come into my code here, so this is the process of updating. If I come into Unity, and let's say I go into my scripts, I go to my box script. This should open it up in Visual Studio. All right, I'm just going to put a little comment in here that just says small change. Save it. So now when I go back to GitHub Desktop, notice it's noticed some changes. Now, some of those changes came as a result of me actually changing that one file, but other ones, and let me just show you the connection here. So I'll go up to here. We'll go ahead and look. I haven't published yet. All I've done is I've made a change to Unity. Haven't done anything with GitHub. So I'll go into my assets. I'll go into my scripts. I'll go into my box script, and we see that that thing is not there, right? So I'll go back to Git Desktop here. I'll just put a made small change. Probably you want to have, if you're doing some major stuff, you want to have a little bit more descriptive thing than that, because the idea is that GitHub saves all the different iterations of your file. So you can get to old versions. Like if, hey, it worked last week. What's changed between last week and this week? Again, we probably won't be using it for that, but GitHub supports that kind of thing. So I'll just say made small change. I'm going to commit locally. And remember, the very first time we did this, we published it. Now, when we have changes local that we need to update the cloud, we push to origin. All right, so now my cloud is updated. If I come back in here, I'll just refresh the screen. Notice here's my small change. The change is now there. Make sense? So that's the cadence of using GitHub. Go ahead. Okay, I'll have to look at it. All right, so your homework for next class is in the event that you didn't have your code working for today, get that working and get it uploaded to GitHub and give me a link that works. Okay, so the idea is after this next assignment is submitted, I should be able to trust that everybody has a working GitHub. Make sense? So between now and next class, if you're having problems doing that, message me on Slack. We can see if we can get it worked out that way. Everybody has a working GitHub. Questions, comments, concerns, bribes? All right, I will see everybody on Wednesday. And what I'll go ahead and do is I'll just copy my repository here and I'll go ahead and throw that into Slack so you have my link.
I think I was getting the same here that he was getting.
Okay, give me 1 second.
You are? Yeah.